Shopify's point of sale system helps you sell at every stage of your business with fast and secure.
Hello, how are we doing? Sound check. That's fine. Hello. I'm gonna check on my phone, I think. Hello guys, how we doing? I'm just adjusting the volume. Alright, I'm happy with that. Okay. I'll give it another minute and we'll get started. I think that's a bit loud for me as well. I'll put this up to 4%. And it should be okay with that. Alright guys, make sure you got your calculators for this. Definitely have your calculators because we're doing stats today. I'll be going through 3 methods of how we're going to do this. When we're going through binomial distribution specifically. For this Venn diagrams, it doesn't really matter. But when we're going through binomial distribution, we're going to need like, there's 3 methods really. You have your 991EX calculator. You have the CG50, the chunky calculator. I'm going to get mine out as well. This chunky calculator. And then there's a formula book method as well. If your calculator is just completely disabled. So we'll sort that out as well. But I'll be mostly using the CG50 method. I really recommend you do get that. It saves so much time. Okay, how are you doing, guys? Hello, everyone joining. Hello. Give another minute and then we'll start. Okay. Okay, cool. Alright, you know what? Let's start. Hopefully you guys can see this alright. Can I put this on clear display? Yes, you can. Okay, cool. Right. Venn diagram shows these probabilities that the student at a sixth form college study that students at a sixth form college study certain subjects. M represents the event that the student studies mathematics. P represents physics. H represents history. Okay, this is not too bad at the moment. We know that P, the probability of maths, is equal to the probability of physics. Let's work that out. So, probability of maths is just going to be 0.32 plus P. Probability of physics is going to be P plus Q plus 0.7. Okay, we've created one equation so far. Okay, our other equation, okay, at the moment we can't solve this because we have 2 unknowns. So either we need to work out P first, or we need to work out Q first. Or there might be some sort of simultaneous equations. Let's see. So, another thing, right? The whole thing adds up to 1. Okay? Adds up to 1. When you add all the probabilities, it adds up to 1. So I'm going to do that. So 0.32 plus P plus Q plus 0.07 plus 0.13 plus 0.1 is equal to 1. Hopefully this is ringing some bells. Okay. Hello guys. How's everyone doing? Make sure you have your calculator. Get some paper as well. I'm just going to add this all together. 0.13 plus 0.1 is equal to 0.62. I am also recording this session today. Whoever reminded me yesterday. So I've gotten that fixed. And I will get it posted later on. It'll be on the YouTube channel. If you just search at StudySphere Tutors. Just the same username as this, just put at in front of it on YouTube, you'll find the channel straight away. And I'll just post it on there. The whole, 1 hour 30 live. I might do a little cuts here and there though. Alright, so we have this, and we have this equation here, and we have this equation here as well. Okay, so from here, right, I'm going to try solve for either P or Q. I'm going to simplify this purple equation, so I end up with 0.32 is equal to Q plus 0.07. Right, I've just cancelled out the P's. So in the first equation, I could actually work out Q. I just didn't notice that. So I'm just solving for this. Guys, if you do have any questions, make sure you're telling me. Just put them in the comments. I am reading the comments as I'm doing this. It's right in front of me. And then from here, I can work out P as well. I'll just substitute in. So P gives me 0.38 minus 0.25, 0.13. And then we can, of course, check this. If we put them into our original equation, this should all add up to 1. If there are any disagreements, please do tell me in the comments. But these are the two values I got, and they look pretty nice values. So, yeah, I'm happy with that. Okay, next question. Events A and B are mutually exclusive. Okay, I wonder if anyone remembers what that means. Thank you very much, Alha. Thank you. Mutually exclusive. Probability of A is 0.2. Probability of P is 0.4. Okay, does anyone remember what mutually exclusive means? If not, I'll explain it in a sec, but I need some contribution, guys. What does mutually exclusive mean? Thank you very much. You forgot. Good, Waka. Good. Event can't occur at the same time. Okay, so 1 can't equal 2 at the same time because they're mutually exclusive. What else is mutually exclusive? That's all I'm gonna say, and that's the only examples I can think of. A and B, so these are gonna be our two circles, like so. That's A and that's B, and that's fine if you forgot, Dilsheen. That's why you're here today. Hopefully this is ringing some bells. So if we know that A is gonna be 0.2 and B is 0.4, the rest is gonna equal, because we also have to remember that this equals to 1. Okay, 0.4 plus 0.2 is equal to 0.6. How much do we have left? So we're gonna have 0.4 on the outside. Okay, always make sure when you're drawing your Venn diagrams, you draw the square outside as well, the rectangle outside as well, because that actually you can lose a mark for it. Okay, so be careful. A or B, so probability A or B is just 0.2 plus 0.4. That's 0.6. Okay, A, but not B. So we just want this. So that's going to be 0.2. Neither A or neither B, that's going to equal the outside. Okay, and that's just 0.4. Very nice. Very simple. I hope. Okay, please do tell me if you have any questions. And we're going to go to the next question. We have some independent probabilities. The probability that A and B, the events A and B are independent, and the probability that A is 1/3 and probability of B is 1/5. Of course, Delphine. Okay, so first thing I'm going to do, right, I'm just going to draw A and B like so. Yeah, that's where it gets a bit more complicated. I think I might have that in here. I'm not 100% sure. Other ones. We'll go through those as well. So probability of A is 1/3. Probability of B is 1/5. If they're independent, yes, it's 1/15. Okay. How did we get 1/15? We got 1/15 because if they're independent, write this down. You multiply. Good. If independent, then your center bit times probability of B is going to equal probability of A and B. Okay, this should really be like a curve, like so. Okay, I don't think it's in the formula book. I'm going to be honest. This is just from memory. Someone can correct me, but I don't think it is. I'm going to double check for you guys. But you're going to have to remember this. If it's independent, sometimes you're going to have to write the statement. Let's check in the stats booklet. Don't see it. Yeah, it's not there, guys. You're going to have to remember this one. Yep. It's not too bad though. If it's independent, you just multiply the 2 bits and you get the center bit. Very nice. Okay. And yes, the correct answer was 1/15. Cool. Next question. If there's any questions, make sure you guys are telling me. I'm going to keep on repeating it. Because I know there's a lot of people who just sit there and are like lost. And I don't want that to happen. I'm going to zoom out a bit more. Okay. Venn diagram shows the number of students in a particular class who watch any of the 3 popular TV programs. Find the probability that a student chosen at random watches B or C or both. Okay, so you want B or C or both. Okay, so we're wanting B or C or both. We're going to add them together. Okay, we're going to add them together. And I get, I'm just using my calculator here, I get 26. In total, how much do we have? We have 30 in total when I add all the numbers together. So that's all my students. And that's my probability. Done. That's it. Now, part B. I want you guys to try part B by yourself. Okay? If they are statistically independent. See what we did above? I'm going to slightly scroll above so you can use that as reference if you did forget. You should be able to see that. Prove to me, tell me if B is statistically independent or not, and just give me a value with it. Okay, just give me a probability, what you got. Or 2 probabilities you might get. Okay, give that a try. In the meantime, I'll just check the music real quick. Hear the background screaming outside more than the actual song. Hello guys, and you guys that are joining. I'm gonna go close my window. I've only opened it because it's boiling, but that'll do. Just turn my fan on. Of course, you want to do a reaction video. Okay, you know what, I'll try. Alright, okay, for this, probability of A is equal to 7 over 30. And the probability of B, I did maths, further maths, biology and chemistry. Probability of B should get 19 over 30. Okay, I'm going to multiply them together. I get 133 over 900, which is not equal to 4 over 30. Therefore, they're not independent. Boom. That's it. You think chem's long? When you get to year 2 chem, that's when it gets a bit more, it gets a lot longer with your mechanisms. Organic, inorganic gets too long. But my favourite honestly is just physical, because literally all maths. Because what I did right, you use like a kinetic energy formula for one of the questions for what is called time of flight. I love that. X is 2.5. Jump straight to it. Oh, you started it. Oh, fair enough. Fair. I did AQA for chemistry. AQA. Wow. You got to pressure and rates already. In year 1. Ah, okay. So you might have different. So I think for OCR, a lot of the times, right, especially with GCSE, I've heard this with GCSE, they do this stuff a bit more different. So your year 2 stuff might be year 1, but with like slightly easier, and it's not as developed. Probability of X. Yep, cool. I'm happy with that. What value did you get? 0.25. Yep, we just add all the values together and subtract from 1. X is 0.25. What am I studying in uni? I applied for dentistry. I didn't get into dentistry. So I'm reapplying this year. But if not, If I don't get any again this year, then I'm just going to do something like finance or economics, something like that. Why am I doing maths during the summer holidays? Very good question. I'm doing maths during the summer holidays because, one, year 12s are going into year 13 because they've forgotten everything. Two, I am a tutor and I want to try to get more students as well. So this is a little bit of my advertising, and people can see how I teach, and if they like my style of teaching, then yeah, might get some students. Determine when they're independent. To be honest, this is a bit more algebraic. You know what? This is a bit more algebraic. Let's do it. If I know that x is equal to 0.25, I'm gonna check that. Yep. Okay. If x is equal to 0.25, we can just add it together. The probability of a is equal to 0.65. To be honest, I thought this would be a bit more algebraic, but it's not. And then we just multiply them. Equal to 0.3575 when we multiply them, and that's not equal to 0.25, so it's not independent. Very simple. Independent, I'll skip that. Let's do some tree diagrams. I think I have some more Venn diagrams later on, but I think this is a tree diagram. Is it a tree diagram? Yeah, it is. Okay. See what you can remember with tree diagrams. Have a go at it. And this is how we do it. No point in doing this. Of course, yeah, they'll ask you year 2 stuff. But when you're going from year 1 into year 2, if you don't have your foundations, again, this is the main thing for maths. If you don't have your foundation, you can't do year 2. Okay? So it's really important for you to understand how probability works. I know some of you guys have done further maths as well, so you probably did a lot of this already, and you might find it easy. That's completely fine. But this is for the guys who want a quick recap, and I've completely forgotten everything. Did year 11? Did further maths? Yeah. I wish you the best of luck, Ibrahim, for year 12 then. But soon, I am thinking about doing a year 2 session as well, but I don't think I'll do pure. I think pure is such a big topic. I could do specific things that you're unsure about, but I don't want to do it because you guys will have just started year 2, and that's for your school to teach. I'm from Leeds. Alright, let's do this question. If you guys have started, good. 7 beads. So initially we have 7 beads, 5 blue beads. 7 green beads, 5 blue beads. And then not replaced. Second bead is then taken from the bag. Okay, first bead. Okay. First bead, so we have 7 over 12 for green. Actually, that shouldn't go there. Green and blue. 7 over 12, 5 over 12. And we're going to extend this along. So it's going to be 6 over 11 because we have 1 less. Amazing. Thank you for the heart. Thank you very much. And 5 over 12. Green. The probabilities should not go there. Keep putting it there. How did I go with that? I was looking around on how to do it. Because on day 1, right? On first day, I was advertising. I was making all the videos. And then I found out, oh shit, you need 1,000 followers to go live. And then on my PC, I found out there's a thing called TikTok Live Studio. And I just tried it. And I was like, yeah, cool. That's worked. So I can't go live on my phone. It won't let me do that. But I can go live from my PC. And that's how I'm doing it. I did biology, chemistry, maths, and further maths. Honestly, I don't recommend bio for anyone. Bio was by far my least favourite subject. I hated it. Absolutely hated it. So that was me. So imagine doing English GCSE. That was me. That's how I was feeling the entire 2 years. Okay, probability that both are green. You want this one and this one. I'm just going to multiply it. 42 over 132. That's part A. Part B. Bio is all just smart scheme, man. Literally about to. AQA is horrendous with it. I heard Edexcel is slightly better as well. Chem, maths, business. I heard business is easy. That's what I heard. but just bear writing. Chemistry, some people find it hard. It's either you find chemistry easy or hard, honestly. In my opinion, I found chemistry quite good. The only bit I found hard was inorganic, because it was remembering, and organic as well, with with some of the 6 markers. But you'll be fine, bro. You'll be fine. Different colors, so green and blue and green. That's going to be 7 over 12 times by 5 over 11. Okay, plus 5 over 12 times 7 over 11, and you should get 35 over 66. Cool. You know what? This stuff is very easy. I'm gonna skip through that. Let's do this. Yeah, let's do this. Economics. Actually, wait. I've said economics quickly, but you know what? It depends. It depends on your memory, right? In my opinion, if your memory is very good, you're good at memorizing stuff, it's easier to get a B in biology, in my opinion. Actually, I don't know, because I don't do economics. I really don't know. Yeah, that's why I said economics straight away, because I hate biology. I was predicting an A for bio. I was getting like A's. I would actually never got an A star, I'm gonna be honest. I think I got it once, just because the grade boundary slightly changed or something. I don't know. Like in class exams. Okay. I want you guys to have a go at this as well. We have a mobile phone, MP3 player, and neither. Okay. Find the proportion of students who have both gadgets. Okay, this is a very nice question. In your actual stats exam, there is going to be it's probably going to be a Venn diagram question. I'm not gonna lie. Venn diagram questions, right? When they pop up, they can be hard. They can be so hard. Of course, Grace, we're going to be doing that more towards the end of the session. Right now, this is probability distributions. Actually, here, look, you can see this is a binomial distribution. So here, we're going to be starting that. Okay, so we'll get to that soon. Do not worry. Okay. So I'm going to start with this. So I'm going to say, let's call this M. Actually, no, I'm going to call this probability of P, just because of phone, and probability of M from MP3. Okay. Now, probability of P, that gives me 0.85, and the probability of M is 0.6. Right? And I'm going to draw this like so. That's a terrible circle. 1, 2. That's P and that's M. Now, my outside is the probability that none of them have it is 0.05. Okay? Now my inside within the two circles is going to be how much? It's going to be 0.95, right? So the probability, when you add them together, when you add the two circles together, the probability, you get 0.95. Okay? Now we can do some elimination. We know the fact that probability of the phone is 0.85. So the probability of just the mobile, I feel like I've done that wrong. That's not right. I've written that wrong. My fault. And that's supposed to be probability of UM. Okay, like so. So if we know that this is going to be 0.85, if that's 0.85, then this area here, then the highlighted area has to be how much? 0.1. Okay, just using some logic here. If we know the whole bit is 0.95, using this original information, we know that the whole circle of P, the whole circle of the phone, is 0.85. So that means our remaining area has to be 0.1. Okay? Now we're going to do a bit more logic. We know that the whole area of the mobile of the MP3 is 0.6. So this middle bit has to be 0.5. Okay? And now we can do some more subtractions. 0.85 minus 0.5, that gives you 0.35. Okay, that's our Venn diagram done. Okay, and then from here we can do the rest of the question is really easy in my opinion. I'll skip out D. Okay, I'm pretty sure, I'm pretty confident that a lot of people know how to do it. If you're unsure, put a comment down, I'll go through it. Part C, student is chosen at random. Find the probability that they only own a mobile phone. So that's going to be 0.1 because it says only. Okay, the 0.1, that's it. Happy with that? I'm just going to check, is this something similar? I want another example like this. That's the tree diagram. That's tree diagram. I'll leave tree diagrams. You don't really see them a lot. I think it was Alex that said that before. You don't really see them. Okay. Probability distributions. We're starting to go more towards binomials slightly. Okay. Discrete random variable x has the probability distribution of that. Actually, this is not even too bad. It's not bad at all. You can probably do this. What's the probability of 1 between bigger than 1, less than equal to 3? So we don't want to count 1. We just want to count 2 and 3. I feel like you guys can't see the numbers. So I'm just going to write them a bit more bigger. 1, 2, 3. That's 1/8. And that's 1/4. That's 1/2. And that's 1/8 as well. Okay. So we want bigger than 1, less than equal to 3. So that's going to be 2 and 3. We're going to add the two probabilities together. 1/2 plus 1/8. That gives us 5 over 8. And exactly the same for the other ones. Less than 2, that's going to be 0 and 1. That gives you 13 over 40. I'm going to check that. No, it doesn't. It gives 3/8. Don't know why I got 13 over 40. Okay, and the last one, bigger than 3. We don't have a bigger than 3, and that's just going to be 0. Okay, sometimes I do just randomly check, do these probabilities add to 1? It's a good habit to get into because sometimes they don't. They throw that in there, but I'm assuming it does for this question. Okay. This question, okay, this is a bit more algebraic now. This is actually a lot more algebraic. Let's see what you guys can do with this question. Okay, try work out what A is, and what C is. Okay, have a go at this. I'll give you guys a minute, and I'll go through it afterwards. I'm gonna have a sip of water. Oh yeah, I managed to fix the bracket issue. The random brackets that were popping up on my screen. It turns out it was just my tablet. It was just the slidey thing. I just turned the setting off for that. Because it was for like a zoom in thing and it didn't actually zoom in. Okay. Alright. Display capture. Oh, camera. And saturate my face. There we go. Beautiful. Right. Biased 4-sided dice with faces number 1, 2, 3, 4 is rolled. So first thing what I'm going to do, right, I'm just going to draw a probability distribution just from there. 1, 2, 3, 4. Okay, you don't really even need to do the side bits, whatever's here. I'd never really do that. As long as you know what the probability distribution means, cool. Okay, and the probability that x is equal to x, you know what, I'll do it. So probability that x is equal to x is equal to k over x, and we don't know what k is yet. Okay, but our top row is the value of x. So here, this is going to be k over 1. I got this 1 from here. The next one's going to be k over 2. Next one's going to be k over 3. Next one's going to be k over 4. And if we remember, this is a key thing for every single probability question you do. All the probabilities, they add up to 1. Okay? So if we find out that this adds up to 1, I'm just going to simplify this really quick. I get, just using my calculator, I end up with 25 over 12k. You know, I'm just going to, before I do that, I'm going to rewrite this. K over 1, K over 2, plus K over 3, plus K over 4 is equal to 1. Simplify this, I get 25 over 12k is equal to 1. So I get that k will be 12 over 25. Boom. And then from here, best thing to do really is just rewrite the probability distribution, get rid of all the k's. I'm going to copy this. Copy and paste. There we go. That'll do. Let me shrink this. Perfect. And then I'm just gonna rewrite the probabilities, because then I can do part C a lot more easily. Right? So for probability of 1, that's just gonna be 12 over 25. Probability of 2, that's gonna be 6 over 25. Probability of 3 is going to be 4 over 25. Probability of 4 is going to be 3 over 25. Okay, and then I can do part C very nicely. I just add the probabilities together, like so. Okay, if you have any questions for that, please do ask me on how you do it. I'll just do question II. I'll just do this II. Because we can get to the more interesting stuff. So less than 4, bigger than 1, so we're just looking at 2 and 3. That's going to be 10 over 25. For these probability questions, unless it does say simplify, you don't have to simplify. I'm going to be honest. It's just easy to do without simplification. Even in the mark scheme, it's never mentioned it. A lot of the times it gives you the unsimplified answer in the mark scheme. I would say don't bother with it unless it says specifically simplify. I think I've seen maybe like 1 or 2 places where I've seen it before. Okay. Next question. I'm just trying to see where binomial is. Okay. The random variable x has this probability function. These are the probability functions. How are you guys with probability functions? How are you guys finding it? Finding it easy, a bit hard? Because I feel like it's not a bad topic, but you just have to be a bit careful with it. That's all. So I have 1, 2, 3, 4. I've got those numbers from here, right? I'm just gonna put kx. So kx for 1, that's just 1 times k. That's just gonna be k. For 2, that's gonna be k. 2 minus 1, which is k as well. 3, that's just gonna be 3k. 4 minus 1 is 3, and that's gonna be k like so. This is also going to be 3k. I add the probabilities together, I get 6, 7, 8, 8k is equal to 1, because if I add all the probabilities together, I get 1. K is going to give me 1 over 8. Perfect. Now find the value of k, I've worked that out. Find the probability that x is bigger than 1. I'm just going to add all these together, that's going to be 7k, which is 7 over 8. Very easy question, nothing too difficult. I hope that makes sense. Please do tell me if it doesn't. This looks like I'm skipping that. Let's go right to binomial distribution. Just want to see, did I put some notes here? I did. Right. Okay, so we have 3 ways. We have 3 ways of doing this. Okay, we have our formula book. We have our 991EX. I'm going to bring that up as well. I can find my mouse. And we have our CG50 method. For the rest of the thing, I'm going to be using the CG50. But I also do have the 991EX emulator. Let me bring this up. Okay. Menu 1. Okay. Add source. Give me a second, guys. Display capture. Oh, not that. Here we go. Right. Okay. You guys can see that. Probably familiar with this type of calculator. Okay, so you have these type of 2 calculators. I recommend this bigger one. Okay, a lot of you guys will have the small one. That's probably what schools told you to get. But even if you do A-level maths, they might say, oh, only the further maths students get this big one. Just try get it. Okay, look on Facebook. It's not that bad. It's like £70. Trust me, it's an investment. I can literally guarantee you'll go up by a grade. If you're like a grade D, you'll very quickly go to a C or B with this calculator. Okay, it's so useful, and every single person that has it has an advantage over you. I'll be honest. Okay, so make sure you get it. See if your school can rent it out. Okay, first method I'm going to do, right? I'm going to show you the 991EX method, because that's probably the one that most of you guys have. Okay? The first random variable of doing this, x, b, 12 1/6. Okay, that's our probability. And I'm just going to put this into my calculator. And if you want probability that p equals something, okay, you're not going to use CD, but you're going to use the PE function. So I'm going to go to this calculator, and then I'm just going to type, go to menu, go to distribution, and I'm going to go to binomial PD. Because if I use CD, that's everything less than equal to. Okay, so I'm going to do for list, no, not list, oops, variable. To variable, okay, so my x is going to be 2, my n is going to be 12, and my probability is 1/6, and that gives me 0.296. Okay. Same thing for the next one. I'm just going to jump straight to C, part C. Right, menu. Instead of using PD, I'm just going to use CD1 this time. And I just want less than 1. Less than equal to 1, that gives me 0.381. Okay, you don't have to put any sort of working out for this. You can put straight the probability, get the full marks. Okay, you know what? I'm not even going to bother with the formula method, because you shouldn't. Honestly, you shouldn't be doing that. Okay, I'm not going to do the formula book method. I'm going to jump straight to the CG50. Because if you're using the formula book to do these type of questions, you're costing yourself marks. You're really costing yourself. Because you have such a big disadvantage over students who do have the calculator. Right. Okay. Statistics. Distribution. Binomial. BCD. Okay, don't even use BPD. Okay. So I'm going to change this to, this should be variable. Right. Okay. So first one, I want x equals 2. That's going to be 2, 2. X equals 2. Okay, my num trial is going to be 12. My probability is 1 divided by 6. Okay, boom, 0.296, exactly the same value as before. Okay, if I want less than equal to 1, I just change it 0 and 1. A lot quicker. Okay, and you have normal distribution, you have all sorts of different distributions. It's a lot more helpful, right, when you have in-betweens. Okay, when you have in-between like this. Like for example, between 1 and 10 and something like that. So I'm going to go down more and let's look at this question. So the probability that a randomly chosen member of the reading group is left-handed is 0.15. Actually, I forgot something. Why a binomial distribution is valid. Okay, you have fixed number of trials, 2 possible outcomes, failure or success, fixed probability of success, and they're independent. Okay, the most probably, the common one you'll probably remember is the independent thing. Okay. These are the things. Sometimes it asks you why should we use a binomial question, a distribution. In this case, yeah, suggest a suitable model and a justified choice. Okay. So for here, we're going to be doing binomial because we have a group of 20 and we have a probability. Okay. You only have 2 distributions. You have a binomial and a normal. Okay. Don't worry about anything else. Okay. If it gives you the mean or the standard deviation, 99% of the time it will be normal distribution. Okay, so this is 20 and 0.15. That's my binomial distribution done. I just put independent, but always try to include context. Okay, when you're answering that question, add context to it. Okay, so the number of members who are left-handed are independent of each other. Okay, that's all you need to put. Just put a little bit of context, just using the wording from the original question, and that'll give you the mark. Because if you just put the independent, you won't get the mark. Okay, always have context. Now part B. Okay, probability that x equals 7, and that's part A. Part B, probability that x is less than 2 because fewer than. If it's at least 2 or at most 2, then we're using less than equal to. But here it's just going to be less than. Okay. Now I'm going to put this into my calculator. Should I use the? I'll do it both. You know what? I'll do both. Put them both up here. Right. binomial distribution, and you can see which one's a lot quicker, right? 120 and 0.15. That's my first one. That's going to be 0.016, and I'll do the same thing on the other one. Actually, I won't do that on there. For this one, right, what we want to do, I'm just going to convert this really quick to less than equal to 1. Okay, you don't have to do this if you know what you're doing, but I'm just doing it for the sake of just understanding what the numbers are, because when we put them into the calculator, you don't want to put 2, you just want to put 0 and 1, and that gives me 0.176, 1755176. I normally, in my exams, just put 4 decimal places, but 3 decimal places is completely fine. Okay, minimum 3 6 figures. I'll do the same thing for the other one. You're going to be using binomial CD, variable. This one's less than or equal to 1, 20, and 0.15. And that should give you the same value, as you can see. Okay, very nice. The student suggests using a binomial distribution to model the following situations. Give a description. I can't be asked with assumptions. Okay, a sample of 20 bolts. Okay, the production should produce 1%. Possible values, we got x binomial 20 and 0.01. Some traffic lights have 3 phases: stop 48% of the time, wait or get ready 4% of the time, and go 48% of the time. Okay, assuming that you only cross a traffic light when it's in go position, model the traffic number of times that you have to wait or stop on a journey passing through 6 sets of traffic lights. Okay, interesting. So we have 1% of defective bolts. We don't really care about that. Assuming that you only cross a traffic light when it's in the go position, model the number of times that you have to wait or stop. So wait or stop, that's going to be 0.48 plus 0.04. So that's wait or stop. That gives you 0.52 for one of the traffic lights. Okay. If you have 6 traffic lights, that's just going to be to the power of 6. 0.52 to the power of 6. Model the number of times that you have to wait or stop. Okay, we're not going to use binomial on this just because it doesn't tell you all the possible values. Okay, it doesn't say, it doesn't give you like a sample size. That's why. So if you're doing 3 6 sets of traffic lights, yeah, so you just do to the power of 6. And whatever that answer is, I'm just going to do into my calculator. To the power of 6, 0.01977. Okay. This one is going to be a binomial. Right? When Stephanie plays tennis with Timothy, on average 1 in 8 is an ace. How many aces does she do? Okay, so it's not even exactly a binomial. Okay, I'm gonna put it as a binomial for now. Okay, but our average, what we do, we just multiply our n and our p. Okay, so it's just gonna be 30 times by 1/8. That's gonna give you 15/4, which is 3.75. Okay, you could how many aces does Stephanie serve? Technically it's 3. Okay, it's not 4 because that's bigger. She doesn't serve 4. What she definitely does is 3, but you have that 0.75. Okay, what I would do if you do get this question, you don't really get these type of questions. It's a bit more developed, like normal distribution stuff. But you have this 3.75. I would definitely say 3.75. Sometimes your mark scheme can differ depending on like what they're looking for. For example, if it's bags of like seeds or something, then you round up to 4. But in this case, it's 3. So always look at the context. Okay. Next question. Right. So these type of questions, they're a bit more different. Very similar, but slightly different. Probability A, probability B, I won't go through. C, I'm gonna do. Okay. So what you have to do with this, and this is why this CG50 is really nice, because you don't have to do any adjustments. You can put it straight into your calculator. And even they say, oh, you have to put something down, you don't. Okay, literally just put the probability down and you get full marks. So I'm going to put 15, my maximum value is going to be 20, 20, and my probability is 0.4, and that's my answer. Done. Okay, so my answer 1.611, 5 times 10 to the minus 3. That's it. Okay, whereas if I'm using my other calculator, the 991, I'm going to switch that out. What I have to do instead, I have to first convert this into a less than. Okay, this is the same thing as 1 minus the probability is less than less than 15, which is equal to probability of less than equal to 14. And then I work out the probability of x less than 14. Let's bring that up. Like so, 14, that's 0.4. That gives me 0.998, and then I subtract from 1, and that should give me the same answer. Okay, but you can see you can start getting lots of inaccuracies, and it's a lot longer, and that's why I really recommend you do CG50. Okay. As we're doing this though, should I use a CG50 as we're doing this? That's what I'm not 100% sure about. I'll keep on doing 50-50. I'll do it on one and then I'll do it on the other. Okay, just for those that have the 991. Okay, a spinner is designed so that the probability lands on 0.3. I'm skipping that. Oh, that's the end. That's very quick. You know, I'll find some more. Let's do this in the meantime. Spinner is designed so the probability it lands on red is 0.3. Jane has 12 spins. Find the probability that Jane obtains no more than 2 reds, at least 5 reds, and so on. Okay, try this question. I'm gonna bring up some more. I'm gonna try bring some algebraic stuff up, because I really in year 1 Venn diagrams there's not really much. Have you guys done like given, like A given B and such in year 1? Did you guys learn that? I'm gonna try to find some more Venn diagram stuff. Probability. So have a go at this question. Statistical distributions. Leave that. This stuff is too easy. I did stuff a lot harder than this. We're gonna do about YouTube Venn diagrams. I don't know if it'll be on conditional probability though. Set notation, conditional probability in Venn diagrams. 24. Let's see. Right. Actually, you know what? We should be doing this. Yes. Okay, it's gonna go like light white. Just give me a sec. This is more of the stuff that you guys should be doing. Yes. Okay. And what else? I'm not going to do conditional probability. We're also going to do this one as well. Okay. This session might be a bit shorter just because it's stats. Just make sure you just take a screenshot of it. But I'm going to be scrolling up and down, and then we'll go through it again. Okay. Let's see what else I can find. Because I don't think you guys have done given, like A given B and such, like conditional probabilities. I don't think that you guys have done that in year 1. Given that they are independent, that's not too bad. Find the probability that they both win their matches, 0.8. Yeah, we'll leave that. I think I'll just go through these two. Right, okay. Let's go through this one first. Spin is designed so the probability that it lands on red is 0.3. Jane has 12 spins. Find the probability that Jane obtains no more than 2 reds. So you want probability that x, in fact let me make the distribution first, x is 12 and our probability is 0.3. We want probability that x is less than 2, that's A, and probability B is going to be probability that x is bigger than or equal to 5. Okay, and we just put that into a calculator, CG50. I'm going to bring that up. So we get, where's the top half gone? Where's the top half of the calculator gone? Let me find it. It's actually disappeared. Let me restart this. Calc screen normal. Yo, disappeared? Okay, I'm gonna have to restart that. CG50. Give me a sec, guys. If you do have the answer, perfect. Okay. Perfect. Right. Okay, you guys should be able to see that. Not yet. There we go. You can see that now. Okay, statistics. Right. 0, 1, 12, 0.3. So you should, first one should get 0.085. So you should get first. And probability of B, okay, again, this is why I like this calculator so much, you can just put 5 and 12. Okay, technically in the math scheme, right, there is a bit where you do have to put 1 minus P is x less than or equal to 4. But when you put 0.276, right, you get the full mark, believe it or not, because this part is implied. Okay, it's implied by your final answer. So you don't have to put this bit. Okay, so you can just put that, actually even this, don't need, you can just put this straight away. Okay, 0.2763. I've looked at a lot of mark schemes, so I've tried being efficient, trying to take shortcuts, so I know what you get on the mark scheme and what you don't. Okay, we have some more. This is more complicated Venn diagram stuff, and this is more A level. This is the stuff you will see in the actual A level. Okay, ABC with 3 events are that. So we have 3 circles. Probability of A is 0.55. Probability of B is 0.35, and probability of C is 0.4. The probability of A and C is 0.2, and A and B are mutually exclusive. Oh, okay, so they don't have to be like that. It's actually gonna be like so, because A and B, sorry, are mutually exclusive. Okay, that just means that they can't happen at the same time. So what we want, I'm just gonna put the numbers in. A and C, that's gonna be 0.2. Right. Probability of A is 0.55. I'll subtract from 0.2. That gives me 0.35 here. Okay. B and C are independent. Okay, so I'm going to work out what B and C is. So I'm going to multiply the two numbers together. 0.35 times by 0.4. These two numbers get multiplied. That gives me 0.14 here. And then I can do more subtracting to work out my other probabilities. 0.21, and 0.2 plus 0.14. This gives me 0.34. Subtract from 0.4. Ooh, I've done something wrong. I've done something really wrong. That's not right. No, this is right. What have I done wrong? Let's see, let's do some troubleshooting. Because I've just got a negative value in my calculator, that's why. Okay. Is it 0.2? Yes, it is. A is 0.55. I've subtracted from 0.2. I get 0.35. Okay. Probability of B and C, 0.35 times 0.4. That gives me 0.14. Okay. And our probability of B is equal to 0.35. I'm going to subtract. That gives me 0.21 here. 0.2 plus 0.14. This gives me 0.34. So this is just 0.06. Okay. I just subtracted the wrong value, that's all. Okay, so that's the numbers you should get. However, one last thing, we're just going to double check if there's any value on the outside. So I'm going to add all the probabilities together, and that gives me 0.96. So on the outside is going to be 0.04. Always check that, do not forget. Okay, now we're going to work out our what's it called? This questions. Okay, probability of A, not A, and the probability of not B. So we don't want A. So we don't want A at the moment. But then we don't want B either. Okay, so what's going to happen, right? I'm actually going to try to turn this into highlighter. No, it's cool. I'll just change the color of that. Okay, so what do we want? We want not A and not B as well. Okay, anything that's in B we don't want, and anything that's in A we don't want. Okay, so that's what our area looks like. Good, Ibrahim. It's going to be 0.1. Okay, next question. A is, in fact, I will leave that afterwards. We're going to do the stuff that's inside the brackets first. So you want B and not C. Okay, so first I'm going to do not C. What's not C? Not C is everything outside. Okay, but I want it to be inside of B. So it's going to be actually not that. It's actually going to be just this. Okay, it's not C, but it's everything that's inside of B. There's only that. Okay, and we want A or that. So it's going to be that. Okay, that's our area. Cool. It's a bit tricky concept. Is it 0.76? Let me check. Yes, it is 0.76. Well done. Perfect. You know what? I like the green color. It's easier thing to see. All right. Again, we're gonna do the same thing again. A and C is here. Okay, but we don't want it because of this prime symbol. So it's gonna be everything on the outside. So we don't want A and C. or we don't want B either. Okay, so not B is all of this around, and not A and C is all of that around. So we're avoiding, right? I'm going to highlight the stuff that we don't want. We're avoiding this, and we're avoiding that. We don't want those two. Okay, so ignore the pink. We don't want the pink. We want everything else outside. Okay, that's A and C, or should be this as well. Should be that as well. Or all of B. Okay, so we want everything outside. So it's going to give you 35, 0.35 plus 0.06 plus 0.04 should get 0.45. Okay, so we don't want the pink. Okay, these type of questions are a lot harder to understand because of our notations and stuff. But if you can get your head around it, you'll be be doing really well. Okay, make sure you're asking questions if you're unsure. Next question. Members of a school book club read either murder mysteries, ghost stories, or epic fiction. Okay, so we've got 3 different circles. We've been given some probabilities, and okay, let's draw it. So I'm going to draw 3 circles like so, and I'm going to draw the square outside. Probability of M is 0.5, G and E. Okay, M and G. So M and G is this. That's M and G. M and G is going to give you 0.3. Given that no one reads both ghost stories and epic fiction, so M and E, this is going to be 0. In fact, that's not going to be 0. It's going to be all of this. That's 0. Okay, so we have 0 here and 0 here. Okay, do you understand that? Do we know why both of them are 0? Because if I get rid of this G temporarily, right? If I get rid of that G, M and E have to be 0. The whole thing has to be 0. Okay, and that bit includes the center bit. So both of them have to be 0. Okay, so that means that M and G here, that means that if that's equal to 0.3, that means this little section here has to equal to 0.3. I've ticked that off. Cool. Now the probability of M here is equal to 0.5, so that means this part has to equal to 0.2. Okay, all of this section here, all of that section is equal to 0.5, and I worked that out, that's 0.2. Cool. Tick. Probability of G is 0.4. Probability of G is 0.4. In fact, I've slightly done this wrong. It's not this that's 0. I've done that slightly wrong. That's supposed to be ghost and epic. So that 0 is supposed to be here. And I don't know that's 100% 0. Okay, so I'm going to go back on what I said earlier. But it's exactly the same concept. I've just slightly misread the question. That area is supposed to be 0. And I'm looking at ghosts. If G is 0.4, this becomes 0.1. Okay. Do I know anything about epic and mystery? Has it told me anything about independent and M and G? Yep, draw Venn diagram. Both ghost stories and epic. M and E we haven't been really given much, which I'm a bit unsure about. Probability of E is equal to 0.6. Okay, so if the probability of E is equal to 0.6, let's call this A, B, and C. Okay, B plus C. Okay, that's all of that. Okay, B plus C is going to equal to 0.6, and A plus B is going to equal to 0.5. Okay, that's how I've done it. I've just added some letters in. If you don't like that, I could try to explain it another way, but that's just, I think it's a nice way of doing it. From here, we can do simultaneous equations. I'm just going to write them on top of each other. B plus C is equal to 0.6. Okay, A plus 2B plus C is equal to 1.1. Is this the right way of doing it? I feel like it's not. I'm not very happy with this at the moment. Another troubleshooting question. Very nice. Very, very nice. I don't like this. I'm not happy with that. I'm going to get rid of it. Let's see what else we can do. I do want to do the log, not the log, there's a rule for it. You've gone that M is equal to, yep, I know that, M equals 0.5, correct? So that's in the question. We've got 2 areas, that's why. And it hasn't given us any information about it. Draw a window and control it into 0.2. How do you get 0.2? How do you get 0.2? M and G 0.3. Let me skip this add. try. Let me give it another try. I'm going to add all the probabilities together. A plus B plus C plus 0.4. We have another probability on the outside. Is equal to 1. A plus B plus C plus D is equal to 0.6. A plus B is equal to 0.5. C, B plus C is equal to 0.4. If I add them together, A equals 0.5. Nope. Guys, I am stuck. That's okay. That's completely fine. I'm gonna find a method to do this. I'm gonna do it live right now. I'm gonna do it in front of you guys. Okay, you know what? Let's skip to the next part. Probability of MUG, M or G. We know that this whole section here has to equal to 0.5. G, we know 0.1, so that's 0.6. Okay, I. That's completely fine. You can stay if you do foundation math. You can see how A-level maths is. We welcome everyone. M and G is 0.3. Okay, or M and E. M and D, so it really wants us to work out M and E. And that's going to be, we don't know what M and E is going to be. I feel like I'm missing part of the question. G, P, and E. Given that no one reads both ghost stories and epic fiction, and M and G, ghost stories or epic fiction, that's 0. Is A-level maths hard? I found it good. Honestly, I found it good, but you can find it hard if you don't put in the proper work in. That's all. And there's different parts of the section, parts of the spec that are hard. I found moments really hard in my opinion when I was studying it, and then right towards the end of year 13, I hacked it. Finally hacked it. I put like a good 2-3 hours, like by myself, trying to figure out a rule for myself. Because I think, right, if you try to figure it out yourself and try and make like a way for yourself to remember it, because there's different ways of doing it. Like for example, the way I teach might not be the way your teacher teaches, and it's something that it might not stick in your head. But that's completely fine as long as it stays in your head. Okay, that's the main thing. And that's the thing with math. There's so many different methods of doing the same thing, and that's why I enjoy it as well. Anyways, I'm gonna redo the question. I am going to redo it because I feel like I'm missing something very important. M and G is 0.3. Ghost stories and epic is 0. That's 0.5. That's 0.5. Oh, that's why. Okay. So if this section, yeah, it was right in front of me, guys. If this section here is 0. Show you guys what they've given me. Look, all that crap explanation. Why are they showing me X, Y, Z? As you can see, that's not the right method of doing it. So I'm gonna show you. I'm gonna read it. I'm gonna simplify it down. Okay. Since G0, the whiteboard is wrong. Okay. I'll give you guys another minute, have a go at this question, and then I'll go through it, okay? Tomorrow, what we're doing, actually, I feel like we could go into tomorrow's content even now, because I was planning on doing more binomial distribution, because there's literally just a bit of binomial distribution in this. I was hoping I was going to do a bit more. We could do more now. Do you guys want to do binomial distribution? Yeah, it's a lot better, you know what? Tomorrow is going to be some hypothesis testing. No, we'll do that tomorrow. I'll save that for tomorrow. And then there's some more mechanics. Today's session was really short. I planned it to be short, I didn't want it to be this short. How you guys doing? Just have a go at this question. and then I'll go through in a minute. Okay, so what we have is hockey, that's 0.5, cricket is 0.4, and the probability that they play both is 0.25. Hockey, we're going to subtract from 0.25, that gives us 0.25. Cricket is 0.4, we're going to subtract again, that gives us 0.15. And I'm going to double check, do we have any probability on the outside? We do. Going to subtract from 1, that gives me 0.35 on the outside. And then I can work the notations out. H and C in the middle, 0.25. I don't want H, but I do want C. If we go to my highlighter, it's not selecting my highlighter. You know what, whatever. So I don't want H, but I do want C. So that's going to be 0.15. Not C, but I want H. That's going to be 0.25. There we go. Like so. Very nice. Okay. You know what? Let's go and start a build tomorrow. Why not? See what you guys can do with this. I'll put these 2 questions on. See what you can do with that. And I'll go through them. Only these are going to be the last 2 questions, and that's it. And that'll be end of the session. It'll be like 1 hour 20 now. Random variable x binomial b, x distributed with the binomial is with that, and we just put that right into the calculator. And again, this is why I love CG50, because we can literally just put the values right in. Whereas you have with the other calculator, you're gonna have to mess around. So I'll do part C, right? 11 and 15. My number is n is 40, distributed with probability 0.47. And you can see this gives you the number so quick. It's too nice. Other one as well, 11 and 16, 0.230. Easy peasy. I know, right? A levels are done for you. But this is for people going from year 12 into year 13. So you can go share it to them. Let's do the next question as well. Factory produces a component for the motor trade. 5% of the components are defective. Quality control officer regularly inspects a random sample, 50 components. So we got a random sample of 50. We got 0.05 as well. So what I'm going to do, I'm going to distribute it. 50 and 0.05. Going from year 12 to year 13. Yes. I'm going to remove the calculator off the screen. It's in the way. Okay. So A. Fewer than 2 defectives. Probability that x is less than 2. B. More than 5. So probability is x is bigger than 5. Okay. So we can put that into a calculator and you can get the numbers for that. That's good. That's really good. The officer will stop production if the number of defectives in the sample is greater than a certain value D. Given that the officer stops production less than 5% of the time, find the smallest value of D. Okay, so we want probability that x is bigger than something is equal. Actually, I'll put D. Probability is x is equal to D is going to be less than 0.05. Okay, so there's 2 ways of doing this. One way, you do it algebraically, which I don't recommend. It's going to be super long. Method 2, you just point to your calculator and just trial and error. Okay, and that's what I would do. So I'm going to distribute 50 with 0.05. top values, you just want it to be bigger than something. So I'm just going to put, for example, 10 and 15. So that's too small. That's really small. Let's try 4. Okay, so 4 we get 0.234, too big. Let's try 8. 8, okay, we're getting a bit closer to the 0.05 value. Let's try 6. Okay, we got 0.037. How about 7? Okay, 7 is too small. So 7 is just under. So 6, this is what you're going to need to put in your thing. Probability that x is bigger than equal to 6. Where's my mouse gone? Probability that x is bigger than 6, equal to 6, sorry, is equal to 0.0, what was it? 377. 378, I'll just round it to. Probability is x is bigger than equal to 7 is going to equal to 0.01. What was it? I think it was 1. Yeah. 118. Okay. But you want it to be bigger than, you don't want to equal there. So you're just going to put probability is x is bigger than 6. Okay, so D is going to equal 6. Okay, and that's it for today's session, guys. I've cut it a bit short just because I don't want to go into tomorrow's session too much. And yeah, that's it. Hope you guys enjoyed. I skipped through quite a bit, to be honest. But I think it was a decent session. We just had one question that was a bit irritating. I'll find out what's going on with that, and I'll figure out tomorrow. Okay. All right, guys. Thank you very much. See you guys tomorrow, 5 p.m. Bye bye. Okay, for the guys on YouTube, right? I'm gonna do the question literally here, because that's this question that I don't like doing it under pressure too much, especially when you're live. You have a bit more pressure. So I'm not live no more, and I can chill a bit while do it a bit more nicely. So let's see what comes to mind. Cannot see shit. Okay. There we go. MNG 0.3. MGE. MNG in the middle. 0.3. No one reads ghost stories. And epic fiction. So it can be like this. Okay. M E G. Okay. I'm gonna okay, that's fine. I'll redraw it like that. M is 0.5, M and G is 0.3. How much do I have left on M? How much do I have left on M? M is 0.5, so this blue section here is going to equal to 0.2. If that's equal to 0.2, then E is 0.6 is also equal to 0.6. If that whole section is 0.2, okay, that doesn't mean that's necessarily 0.4. Doesn't mean it's necessarily 0.4. What about 0.2? That's 0.2. The whole section, that means that it's going to be skip this. Now 0.6. Intersection here, we don't know. You know, this bit's going to be 0.2 for definite. So 0.2. This has to be 0.4. So this is bigger than 0.4. Next. It's no range for it. Just gonna put 0.1 here. MG 0.3. So 0.2. It can't be 0.2 because you assume they're independent. That's why. We told you if we told you it was independent, then you would do 0.2. But it's not. I'm not 100% sure it's 0.2. This whole area has to be 0.2. E is 0.6. So if I chop out the fact that it's 0.6, you're also chopping away a probability that includes a 0.2. Okay, so all of them. Okay. That's why. That's why. A, B, C. If we go back to the question, it says, where's the question? Members of the school book club read either members of a school book club either read M, G, or E. Okay, if they read M, G, or E, that means that they all read a book at least. So it means outside has to be 0. Okay, that's where I was getting confused at. Okay, I was assuming there was something on the outside when there wasn't. Okay, that means that A plus B plus C plus the 2 other probabilities is equal to 1. A plus B plus C is equal to 0.6. Okay, now I'm going to do my other stuff. I know the probability of M is equal to 0.5. So that's B plus C is 0.3 is equal to 0.5. B plus C is equal to 0.2. Okay, I can put this B plus C into here. That means that A plus 0.2 is equal to 0.6. A must then equal to 0.4. Okay, and then I can work the rest out. If this is 0.4, then B has to be 0.2. I believe, if I just go back to the question, probability of E is 0.6. Okay, so that means B has to be 0.2, and C has to be 0. Let me check out the answers. Yes. Okay, so our Venn diagram actually looks like so. This would be 0, that's 0.2, that's 0.3, that's 0.1, that's 0.4. Happy days. That's 0 on the outside as well. Too much thinking. You know what? That's me doing maths, proper maths, after however many months.